Suppose your calculator says you gain 2.1 million joules of gravitational potential energy by climbing one flight of stairs. The display looks authoritative, but would you trust it? A calculator does arithmetic. It can't tell you whether the physics is plausible. For that, we need an estimate and an order of magnitude. An order of magnitude is the nearest power of 10, the rung that best represents a quantity scale. 700 joules sits on the 1000 joule scale, so its order of magnitude is 10 to the 3 joules. The order itself is just the power of 10. 7 times 10 to the 2 joules is a useful rough value, but it is not an order of magnitude. Don't just copy the exponent from standard form. Use the whole rough value to choose the nearest power of 10. Here, 700 is clearly on the 1000 joule rung, not the 100 joule rung. Moving one step on the ladder multiplies by 10. 3 steps means a factor of 1000. There's one condition. Compare like with like. 3 meters and 3000 millimeters are the same height. Put both quantities into the same unit before comparing the orders. Estimation can sound like guessing, but it isn't. A guess is unsupported. An estimate is built from assumptions that you can inspect. So start with the person. An adult's mass is roughly 70 kilograms. Now estimate the staircase. A typical riser is about 0.2 meters high, and a flight might have 15 risers. 15 times 0.2 gives a vertical rise of about 3 meters. Finally, take the gravitational field strength as about 10 newtons per kilogram. You're allowed to round. You're not allowed to invent. State your assumptions. Keep the units visible. Use the relevant equation, and keep useful coefficients until the end. Now return to the stairs. The gain in gravitational potential energy is mass times gravitational field strength times the vertical height. Take the person's mass as 70 kilograms, gravitational field strength is 10 newtons per kilogram, and the vertical rise is 3 meters. The estimate is 70 times 10 times 3, about 2000 joules, or 2 times 10 to the 3. Its order of magnitude is 10 to the 3 joules. We estimated the starting values, then we used physics to produce another estimate. That is all a derived estimate means. These values are rough, but the conclusion is robust. Try masses from 60 to 80 kilograms and heights from 2.5 to 3.5 meters. The answer stays between roughly 1,500 and 2,800 joules, still the same order of magnitude. Now compare it with the calculator's 2.1 times 10 to the 6 joules. The two results are 3 orders of magnitude apart, a factor of 1000. No plausible person or staircase explains that. The height was measured as 3000 millimeters and entered as 3000 meters. Correct it to 3 meters and the result drops back to 2000 joules, where our estimate said it should be. An estimate cannot prove that a detailed calculation is right, and a different sensible assumption will change the leading number. But a large mismatch is a warning. Check the units first, then the powers of 10, any squared or cubed quantities, and the calculator entry. In an exam, show 4 things: your assumed values, the equation, the rough result, and the nearest power 10 with its unit. Extra decimal places do not make the estimate better. Estimate first and calculate second. If it lands several orders from your estimate, investigate before you trust the screen. Next, we begin mechanics, where 30 plus 40 can equal 50 if the arrow points in the right direction.